Hello. Hello, everyone. Can you hear me? Please put yes in the chat box if you can. There we go. Okay, now I can see your yeses. Now everything's working. There were some issues with getting in, so I'm glad you all are here now and for our virtual class for week 2. So I'll give this one more minute just to give everyone a chance to come into the classroom. But I'm glad you found the virtual class. The link on the announcements page for some reason didn't work, so I put the correct one there, the working one there now. But hopefully you all know how to get into the Blackboard Collaborate through the menus as well. But I will double check the links from now on. Make sure everything is working before class starts. So how is everybody today? Are you happy? And I'm glad to be here. I'm happy now that you're all here and we're here together. Okay, I'm going to get started only because we have a lot of material to go through. Good and happy. I like that. Isn't that the best? If you have a positive attitude, a positive outlook, then things just seem to go better. I'm doing well. A little bit of a cold, but I'm doing well. It's cold where I am, and there's a lot of snow and a lot of cold wind, so lucky I'm inside. Okay, so again, we had our first week, so hopefully you liked the way the class worked. You like the material that you're learning, and you are doing the work that you're supposed to be doing. So yes, lucky to have a roof over my head and the warmth. God is good. But for week 1, again, make sure you go over the topics. I did give you a little bit in the office hours. If you were not here for office hours on Monday, I did put the slides on in the discussion forum. Also, you have the recording. So I went over some good information on Monday and also some practice exercises just to give you some more material to explore so you can master the topics we are learning. Week 2, we are now going to be moving forward and learning about processes and multi-threading. Week 1 kind of introduced you to all the topics, and as we go through the course, you're going to be learning everything in more detail. There are assignments every week, and you do have a Dropbox. This is the first week where you will be completing some exercises in the textbook. So make sure you do that. Look at them. So if you have questions, you can ask them. And then you can work together in the discussion forum as you explore the answers. And also there are some discussion topics I put on the discussion board, again, just for you to write out the answers, and it gives you something to use them as a reference when you study for the exams. Again, you have the exam midterm is in week 8 that covers the material, all the material from weeks 1 through 7. And then week 14, you have the final exam that covers all the material you learned throughout the course. And the exam formats are multiple choice and true, false. But every week I will give you the topics to study, so make sure you write down notes for these topics and also page numbers so that when you review for the exam, you can easily find the material as you study. And also, please make sure to have study groups. Study groups are a good way. You can test each other, ask each other questions, and that helps you then to learn the material. Now, for the course, we will be doing some programming. I believe programming will start week 4. So I did mention and ask you before about Java, and all of you, well, those of you who responded said you did have a Java class. You did do some simple programming, which is very good. So we were looking, when we do the programming, we will be looking at different strategies that operators use. So we're going to simulate operating system programs, and we may simulate signals coming into our Java program and then determine what we do with it. In the office hours, I gave you some code to look at. There was some example code. Also in your book, there is example code. So look through the code just to understand the logic. The code that is in the book, a lot of it is in the programming language C, but you can use it to understand the logic. But when we do have those assignments, I will cover in more detail the code you will need, how to go about creating it during the virtual class. So we will look into more detail when you are asked to do a program, what it is you need to do. And also, if you haven't, look at the programming tools that most programmers use. And those are things like pseudocode and a flowchart. What those are nice for is that it opens up and has you start thinking about the logic for your code, so you can get the logic in these steps and then later put it into the correct syntax. Because the logic is the most important. And if you don't have the logic correct, no matter how good your program is and the syntax is correct, it's not doing what you want it to do. So as we get there, I may even supply some pseudocode for you or flowcharts for you in the beginning to get you used to using these tools, because they are very important. It's easy to type code in front of the screen, but knowing what you're typing and how it should be placed is an important part of programming. So I will, again, I'm going to be there for you to help you. You will have your classmates, so we'll all work together in getting these programs done. And also, it is important that you attend these virtual classes. Administration strongly recommends that you attend these classes. They are required. You do get points for them. Unless there is an extreme emergency, then we do have that substitute, where you would email me a summary of the presentation when you view the recording. But they really urge that you come here, and they may come in and check to see if you are here in the virtual class. So if at all possible, make sure you come to the virtual class, because the class is being monitored and making sure you are here. But if there's an extreme emergency, do let me know, and then we can work out the possible substitute for you. But if at all possible, just come to the class and everything will be better. Okay, so here's the required software. If you have it on your computer, the latest version for Java or the JDK is 7. So I don't know how long ago you did your Java programs, so what version you have. So check what version you have, and it would always be the best to have the latest one that's out there. And as for an integrated development environment, you can use whatever you've been using. There's BlueJ. Some of you mentioned you use BlueJ. Some mentioned Eclipse. So there's BlueJ, Eclipse, NetBeans. Now, depending how skilled you are, BlueJ is good if you're a beginner. Eclipse is if you're okay and you can start using a little bit more advanced skills. because you have to learn how to use BlueJ or Eclipse before you can even start using Java. So learning the environment is important. Being able to download the environment is important. So try and do that now. BlueJ is available off the for download. Eclipse is available for download. NetBeans is pretty advanced. So in the workplace, normally you will find Eclipse or NetBeans. But Eclipse is better if you're just kind of new to programming, new to learning how to debug your programs and set up a program. And there's a lot of tutorials on Eclipse, and I will give you some links too if you are new to Eclipse. But if you're new to all of this, then first start with Java, and maybe as the course progresses, you can switch to Eclipse. So again, that is future concerns. We will visit it again. I'm just telling you just to give you an idea of what to expect in the coming weeks. Any questions on that? Okay. Again, if you have questions, don't hesitate to type them in the text box. Okay, again, I'm going to always give you a summary of the previous week. That'll help you because week 8 is far away. And if you don't keep revisiting your early weeks, it's going to be hard then to study for the exam. You'll have a lot of material. So really start studying now for every chapter you are reading, because this way when it comes to week 8, you don't have all the material to review. You will already be familiar with most of it. So it'll make it easier for you and give you a chance again to master the material. So week 1 was an introduction to operating systems and all the programs it may contain, all the management it does. And then chapter 2 describes system structures and also some of the utilities and services that operating systems offer. And then we also address the kernel, and this is addressed again if you look into chapter 4 when it talks about the kernel. Now we're going to start looking at programming. And when you are programming operating system objects, you will have the classes that are in tune with these objects, and also there is something known as kernel objects. And that's something I did bring up in the discussion. So if you haven't been in the discussion, please do. And if you have, I will be there after the class then to respond to your posts. But it's a good place for you to write your answers so that I have a chance to look at it and your classmates and we can answer them. So I always give you related topics to explore. And remember, every time you write out an answer for the discussion forum, you now have something to review for the exam. And here are the topics for chapter 1, and then the topics for chapter 1. Now, what I will also give you is some practice questions so that this will get you used to the kind of questions you may get on the midterm and final exams, and also kind of like a review. So I do have 5 questions here from chapter 1. I will place these slides in the discussion. So I won't give you the answers right now. I want to give you a chance to look up the answer, and then you can place them in the discussion, or if you have questions about it, also place that in the discussion. So we can work on these questions together. Okay, here's one example question. Which of the following operating systems is not open source? So you may know this right away. Anyway, so you'll see the questions that will be from easy to medium to hard. So there'll be a variety of them. But here it tells you, I'm giving you the question, I'm giving you the section. And you are correct. All of you are correct. You know that right away, Windows. So be proud of yourself and give yourself a hand and a pat on the back. This material you know. Yes, the answer is Windows. Okay, which of the following would lead you to believe that a given system is Symmetric is a symmetric multiprocessing type system. SMP. I'm sorry, I didn't put ABCD. Again, if you don't know this right now, that's fine. You can look at section 132 to find the answer. Again, you have until this is for you to do when you're ready, and look up the answers when you're ready. And if you have questions or you want to put your answers in the discussion forum, please do. I will post these questions there as well. So I'll let you think about this one. Here's another one. The two separate modes of operating in a system are. So you have various modes here, and the section is 1.51. So this is where you will find it. Here we go. We got a couple answers here, D and C. It is actually D. That is correct. But do review this section. I'm giving you these sections for you to review the material. And also the example questions give you an idea of how detailed or what these questions will be like. They're also true false, as I mentioned. The operating system kernel consists of all system and application programs in a computer. Is that true or false? No, that is false. The kernel is just a small portion of the operating system. Again, review section 1.1.3. Application programs, for example, would be like Microsoft Word, Microsoft PowerPoint. That's not part of the operating system kernel. And even operating system utilities are not part of the kernel. So the kernel is just a select group of programs for any operating system. That is something you have to define in your first week's homework exercise in the discussion. So review that to make sure you understand what the kernel really is. It's not all possible programs. It's only a select set of programs. And again, visit section 1.1.3. Here another one. Okay, a system call is triggered by hardware. What do you think, true or false? That is false. Hardware really doesn't trigger anything. Anything that is done in a computer is done by software. Always, always, always. Programs are software. Hardware is just the equipment. And the equipment doesn't do anything or know anything until it's given a program. And once it's given a program, then it's the program that tells it what to do or listens to it to know what it is doing. So this is false. Okay, so that's an example then for chapter 1. Again, review the sections, review these questions. If you have any other, also review the exercises at the end of the chapter. That's a very good way to know then the material. If you can go through all those exercises with no problem, then you're ready for the exams with no problem. And if you have questions about them, bring them into the discussion forum, even if it's a later week. Maybe you started studying, in week 3, and you're studying chapter 1 and you had a question. Please, you can still bring it in discussion forum, because really the questions you have will help everybody in the classroom. So you're more than welcome to do that. Okay, these are chapter 2. So make sure you go through these topics. Write down the definition for these topics. Excuse me. Write down the definition and also maybe page numbers. And also maybe any other detail you think is important. So it's a good way, again, to get familiar with the material, the topics, and to know it. Like for me, I learn better when I write it down. If I use my brain and also my hands as I'm writing something, I remember it faster. So you have to understand what is the best way for you. Some people can hear it and they know it right away. Some people can watch a video and they know it right away. Or some people have to read it to know it. So everybody has their own learning style, so make sure you use those resources that are best for you. Like I said, for me, I got to write it down. I can read it, but if I don't write it down, it doesn't sink into my brain. So depending what's best for you, you might be able to read it and get it right away. My son is like that. He could read something or hear something one time, and it's automatically in his brain, and he knows it like he's a master. But not for me. So use what works for you. Okay. Now we're going with Chapter 2 questions. Here's some example questions for Chapter 2. And again, these sections tell you where you could find the answer. Okay, a blank is an example of a systems program. Anybody know this one? Now, there's a lot of programs. I did mention before, there's a difference between systems program, which is operating system stuff, and systems program help you run the computer system. And then there's applications program. Applications allow you to use the computer to apply to the real world. So the answer here is command interpreter A, because that's something the operating system needs when you type in commands or when you click on a GUI command. It has to interpret it to tell the operating system what to do. These are specific for operating system commands. A web browser applies to the real world. You use it to look up web pages or use the internet. Text formats used for the real world. How to format text so you can read it. Database system is used for the real world. So if you apply it in for the real world, then it's applications. If you apply it to run your computer system, then it's systems programs. And there's more systems program, not just operating system, but the operating system is the biggest one. Very good. Okay, here's another one. A message passing model is easier to implement than a shared memory model, faster than the shared memory model, a network protocol, only useful for small, simple operating systems. I don't know if that's a new A or an old A. But if you're putting A, it's correct. So know the different models for intercomputer communication. That's discussed in section 2.45. Again, a topic, it is listed in your key topics. And then whenever you have a key topic and it lists several different examples, make sure you know each example and how it's different from the other examples. Here we go, example question, and that's in section 2.73. What's a microkernel? We know what a kernel is, but what about a microkernel? If you look at the word, micro means smaller, so it's smaller than a whole kernel. Again, it's in section 2.73. So I think, yes, refresh your memory about what a kernel is, refresh your memory about what it does. We have some examples here. No, not yet. It's not A, it's not C. So now your choices are B or D. No, it's not B. So it's D. Very good. A matter of elimination. Still, yes, D. In other words, it's stripped of all its non-essential components. That's why it's micro. Typically, when you see anything as micro, it's always going to be smaller, but it's smaller in components. Okay, so again, refresh your memory what a kernel is. Kernel is very important because it's kernel objects that you use with your API programming language objects to do programming for the operating system. And it's probably most prevalent in Linux, because Linux or Unix allows you to change. You can program the operating system or rewrite the operating system programs. Not all operating systems allow you to do that. Linux and Unix does, and that's why a lot of programmers or system programmers like Linux or Unix, because you could rewrite it to work how you want it to work. Okay. Proprietary operating systems like Windows or those for specific types of computers do not. So, but kernel objects, and it's something similar, we'll start looking at objects and classes, and then how to use thread classes to simulate and work with the operating system. Okay, another question. System calls can be run in either user mode or kernel mode. We did mention that it's only user mode, or those are the two modes, user and kernel. But when you hear the word system, system is very restricted. So this is false. So think of kernel as the true operating system programs and the true handler of operating system calls. User mode, you may do other things, but system calls are strictly for the kernel. Okay, many operating systems merge input-output devices and files into a combined file because of the similarity of system calls for each. This is true. Again, you can read more about it in section 2.4.3, but that is because typically input-output calls are very frequent. And so this combination in the file is just a strategy to combine, you know, things that are similar. And then it just helps organize it and help it go faster. So again, you could look up these information in that section. So I will be doing this from now on. I'll be giving you example questions for each of the chapters. And also use the key topics and get the definitions and a little bit detail about it. And that's what you could use as a study guide. Okay, now we're on to Chapter 3. Chapter 3 goes more into detail about processes. First, are there any questions on Chapter 1 or 2? Do you feel comfortable with the material? Or it's just still a lot of material that you need to go through again, which is okay too. A lot of this, there's a lot of material, and if it's new, it may take you several times to go through it to understand it. So hopefully with these presentations, with your readings, with the videos, yes, you have to study it again and again. That is correct. That's the only way to know it. There's a lot of definitions, a lot of models, a lot of terminology, and you just have to know it. So there's no other way to actually know it except to study it again and again so that it's just quicker to come to your mind. Exactly. But again, Chapter 1 is an introduction, so you will be seeing a lot of the things that were discussed in Chapters 1 and 2. We will see it again. You'll at least see some of the words. Like we talked about processes and process scheduling in Chapter 1 and 2, but now we're going to look at it in more detail. So the discussion question was to give a definition for the process just to get you starting to think about processes. I did, for those of you who did put it yesterday, I offered some follow-up topics that you can look into and explore just to know more about it. And then here, this presentation will go over the key topics. So you could use this presentation also as a study guide. I just went over these key topics. The other PowerPoint presentations and the resources are the entire chapters. Here, it just touches on the key topics. And then next week, I'll give you some example questions. So this will be helpful as well. So the process, question was, what is it? Well, it's just what the computer process is. It could, sometimes it's called a job, it's called a task, it's called a program. So there's a lot of terminology for the same thing. It all would depend. I don't know when one is supposed to be used over another when it comes to the terminology, because when you mention any of them, everybody will know what you're talking about. So you can call it process, job, program, task. So a process is a program in execution. Process execution must progress in sequential fashion. Yes, and the reason why, remember, this computer is just a machine. It just has switches and pathways for signals to go through. And during this clock tick is when gates are opened or closed and signals go through or stop. So that's why it has to be in sequence, because it's just a series of signals, and they have to be in order, and they will be processed in order. Now, making sense out of all those instructions, so the operating system has a very important job to do. It has to know when gates should be opened or closed. It has to know what signals are needed, what signals they should use, and when they should use it. So just putting them in order is a good way to make sure that they're going to be processed in order. So that's one strategy that's used. But a process itself has a lot of information. The program calls, the program code is also called the text section. And then there's a program counter. There's a stack containing temporary data. And how it's placed on the stack determines the order it is processed. But the stacks are typically used if you have function calls, or if you want to use object-oriented terminology, when you have method calls. So that's when you kind of have to go away from the main program and go and process another mini program known as a function or known as a method. So there has to be some organization to know when you're leaving the main program, going then and processing another mini program, and then when you're done with the mini program, to go back to the main program. There's data section containing global variables. Do you know the difference between global or local variables? Did you learn this when you learned Java? Okay, so you know the difference between local and global, and when you go to object-oriented, then you have private, you have public, you have protected. So these are various parameters or constraints put on the variables. And this determines, too, where it's placed in the stack. And a heap containing memory dynamically allocated during runtime. I don't know if you ever heard of a memory dump or memory heap. This is the memory space that this process is using and the operating system is using to then execute this program. So a program is a passive entity stored on disk. A process is active. So there's a distinction. In order for you to run any program, it's going to be stored in some file, and then that file then is told to run. It has to be in a .exe format, which means it's in machine code so that it can actually run. It has to be translated. You should know that when you did a Java program, you had to translate it into machine code so then it can be processed and executed. So one program can be several processes, and it typically is. The more sophisticated the program, the more processes it contains. So those are all the details about a process with a definition. There is what is known as a process control block. This is what keeps all that information about the process. A process state is very important to determine what level of execution it is in. Is it started? Is it in the middle? Is it delayed? Is it stopped? Terminated? So there's a lot of different states that a process can be in, but then that's how it gets executed, because it goes through these different states. Process number, they have to be identified. Program counter, location of instruction to the next execution. So a counter is like a memory address. Registers, memory limits, list of open files. So this is all the information that is contained in about a process, and it's all needed because there's different programs in the operating system that will look at these different sets of information to determine or have what it needs so that this process can be executed. And this is very similar to a class. And you have a class that has methods, and you have a class that has data or attributes. So this is how it can be related. The kernel has objects as well as your programming language and your API. Okay, then we have scheduling. How do we schedule these processes? There are different strategies for this, but it typically is in a queue. Determining which process is next for execution can be different priorities. You can have some numbered priority, like if you see a number priority 1, that means that process needs to go next, even if there's other processes that are in the middle of execution. So that's how you can distinguish. You may have a large program that takes hours and hours to run, but what if you have an important emergency program that has to come in and get processed? So there has to be some way then to stop that long program, bring in your emergency program so that gets done. So there's a lot of strategies there depending on your industry, depending on what it is you are doing, and if it's a program that can wait, or if it's a program that cannot, if it's a program that can be interrupted, or if it's a program that cannot. So there's a lot of strategies, and that's what we're going to look at. So we're going to look at the code that is used for these different strategies. But in general, it's a queue. Here's the diagram. This is, again, straight from your textbook. So it kind of just shows a flow. When it's ready, it's in the ready queue to go to the CPU. And there's different kinds of information that is looked at, that is stored. Fork is an important method that you will look at, or we will look at. Interruptions, that's something we brought up in Chapter 1. Interruptions, or Chapter 2, both of them. Interruptions, this is when an interrupt occurs, determine for whatever reason that something else needs to be done. We need to stop what we're doing now, and we need to handle this interruption. So interruptions have priorities as well. Some interruptions maybe you can wait, some interruptions cannot. It all depends on the situation. And then there's scheduling. There's long-term scheduler, short-term schedule. So do know the different type of scheduling that can be done. We know that it's very fast because we know the processor works very quickly. And then processes can be described as either input-output bound process or a CPU-bound process. And again, if you have multiple CPUs or dual core or quad-core processors, this then even needs more management and more programs to determine which processor can process which instruction. So dealing with one CPU is a little bit easier than dealing with 4. So again, depending on what your hardware you have will determine how sophisticated your operating system is and how this scheduling is done. And then you have your operations on processes. You need to create a process, something we will be looking at. We know that it has to have some kind of ID. Then if we go back to that process control block, this is the information that you need to place or have or keep about a process. You have parents, you have children. We did look at that a little bit in office hours, but you should know that from your Java programming. You have parents and children of classes. Very similar to the process, or the way processes are programmed. And then you have a termination. Very important not to eat up memory. If you're done with a process, it should be taken out of memory. But also you may want to stop it, abort it. Here's some reasons for aborting it. Child has exceeded allocated resources. Task assigned to child is no longer required. If a parent is exiting, you need to then close out all your children. You can't leave something just hanging in memory. And here's some terminology. If no parent is waiting, then the terminated process is a zombie. If a parent is terminated, processes are orphans. So you definitely do not want orphans. And you don't want zombies. So those are things, again, you have to keep track of. You might be all caught up in processing, executing your processes, that you forget what's sitting in memory and what you got going on. So that is very strict, and it has to be followed closely so that your performance is smooth. Any questions so far? So we talked about what processes are. We talked about the process control block, how processes are scheduled, how they get created, how they are terminated, and here's now how they talk to each other in case they need to talk to each other. Any questions so far? Again, this is just briefly going through the topics. You will get more detail in the textbook. We will have more questions or topics to explore in the discussion forum. And then the questions will be posted there. We'll bring up some questions for you then to get more practice in knowing the material. It's just a matter of knowing it. But also, if you can conceptualize it and kind of have a visual as to how this works, that will then also help you understand the definition and the terminology. So any questions so far? Anybody? Yes? No? Maybe so? Are we still there? Hello out there. Okay, good. Okay, thank you. Okay, inter-process communication. Processes when the system may be independent or cooperating. Cooperating processes can affect or be affected by other processes, including sharing data. So reasons for cooperation: sharing information, computation speed up, make it go faster, modularity, and convenience. Modularity is very big in object-oriented. You have your self-contained, encapsulated objects, but several may be in memory at the same time. So if they need information from each other, again, that's where you go between your public and your private variables. If it's private, then you need to communicate with that class, and you have to use a get method in order to access information on that variable. So if one process or one class needs information from another, and it's a private variable to that class only, then you're going to have some cooperation here, because a get method needs to then be implemented so that the value for those variables can be passed. So that's an example of cooperating processes that are sitting. Those classes are in memory at the same time. So two models of inter-process communication is shared memory and message passing. Now, we already looked at that. It's interesting. There was a question when I gave you those example questions. We already had one from Chapter 2. So again, each chapter kind of introduces you to the next material that it's coming up, because then when it comes up, you're going to explore it in more detail. So remember, if you don't get it the first time, believe me, when you start reading the next one, you'll get it the second time, or maybe even the third time. But you will get it, because some stuff is repeated. So examples of inter-process communication, we have Portable Operating System Interface, or POSIX, shared memory, some example code. In other words, the processes are using the same memory. And the only way they could do that is because they don't each need information at the same time. So that's why when one is running, it could use the memory, and then when it's done, the other one then can use the memory. So it all depends on your processes to determine if this is possible. Mock communication is message-based. So you have the shared memory, you have message-based, and obviously you're going to need something to get these messages or to set up these messages. So you send it, you receive it, receipt of it. So that's another strategy. And then Windows. Windows uses Advanced Local Procedure Call, or LPC. So it uses ports like mailboxes to establish and maintain communication channels. Very similar to any communication or data communication when you're using networking. Very similar to networking. So the client opens a handle to the subsystem's connection port. The client sends a connection request. The server creates two private communication ports, returns the handle to one of them to the client, and the client and server use the ports then to send messages back and forth. Again, very similar to any kind of the OSI model. If you look at the OSI model as to how data communication or telecommunication is conducted, very similar. But obviously on a smaller scale because it only works on one system. So just examples of how processes communicate with each other. One is they share the memory. So they can actually, one process can put a message in that memory for the second process, and that second process looks in that memory to get the message, and then puts it there when it's sending back a message. Mock has message boards. So it's just a location in memory where messages are sent. There's a different location for a message that's sent as opposed to a message that is received. So it kind of juggles the memory spaces. Not the same one, different ones, labeled one for messages sent. Similar to email, you have inboxes and you have a sent box. And then this procedure call, you actually will have ports, which are just channels that are opened up so the messages can flow back and forth through these ports. One is a send and one is a receive port. So again, if you can visualize just how the information goes through, that'll kind of give you a way to remember which one does what. Client-server systems. Again, this is networking. So I do not know. Have you had any network or data communication or telecommunication courses? Did you take any courses that explored the internet or the OSI model? Or did you take it just exploring client-server or peer-to-peer networks? Did you take classes of this type before? Okay, you're doing it now. So that's good. It kind of goes hand in hand. What you're going to be learning now in that class will help you with this class for the little bit. I mean, this class obviously is operating systems for a variety of types of systems, not just client-server or not just network. So what you learn in that class will help you in this class. So if there's something you see in this class and you don't understand or not sure, or you want to know more about it, then use your textbook from the other class and then you can learn about even more about it. So it's a good way to work together between the two classes, because there are something also known as network operating systems that are specific for network communication and traffic. So that is a type of operating system restricted to networks. So that's why we're brought in here, client-server systems. So do know about what these are. Again, this is kind of like a study guide setting up for you now for the exams. So go do review in the textbook sockets, remote procedure calls, pipes, and remote method invocation, especially Java. We will revisit this again because we're going to be doing some programming in it. But here's a chance now for you just to get familiar with it, introduced to it, and have a somewhat of an understanding. But you will find more detail about this information in your network course now as well. And then bring any questions in the discussion forum. Okay, Chapter 4. What are we talking about in Chapter 4? We're going over programming, models, and then your API. So multi-core programming. This is your dual core, your quad core, as I mentioned before. If you have one CPU, it's not as difficult to pass it a process. What if you have more than one? Then you have to determine which instruction goes to which one and why. I mean, it could just be sequential. You have one, you send it to the first processor. You have the next instruction goes to the next. And then vice versa. You can keep passing it to all the processors until it's done. But it may not be that way. You have specialized processor for specialized instructions. So only when you hit those kind of instructions will you use those other processors. So it all depends on the hardware configuration as well as the process in hand. So, so you could be dividing activities, balancing activities, data splitting, data dependency testing, and debugging. So a lot of strategies or challenges as to why you want to use the multiprocessing. Parallelism implies a system can perform more than one task simultaneously. That was your SMP. We had an SMP question already in Chapter 2. So again, this is related to material in the earlier chapters. We're just going into more detail. Concurrency supports more than one task making progress. Single processor core, scheduler providing concurrency. So you can simulate concurrency through software, or if it's actually multi-processing, parallel processing. So it all depends on your hardware and how your hardware is managed by your operating system. There's a lot of different possible configurations. Similar to virtual, you can virtually simulate that you have more than one processor. So types of parallelism, you have data parallelism, distribute subset of the same data across multiple cores, same operations on each. Task parallelism, distributing threads across cores, each thread performing unique operations. So this is just an introduction. We will go into this in more detail and more depth and even look at some code for this. There is some code already. So it works with the software, and the strategies you use in your software will then help manage this multiplicity, whether it be in a processor, in the software, in the threads, and so on. You can have hardware threads or you can have software threads. And you have multi-threading models. I did talk about this briefly when we had office hours. There are some diagrams. There's also diagrams of these in your textbook. So do look at the diagrams to see the strategies here. And that model is what can be used, or at least you can try to imagine what kind of code is used to keep track of all these threads. So do take a look at that, and if you have any questions, bring it into the discussion forum so we all can look at it. Implicit threading. Growing in popularity as numbers of threads increase. Yes, our programs, our tasks, everything we want to do on a computer is getting more sophisticated, more complex. We're all trying to do it faster with the equipment that we have. So now we're looking into virtual ways or implicit ways of getting these things done. So the creation and management of threads done by compilers and runtime libraries rather than programmers. Similar to the old programming, when you programmed in assembly language, you had to specify every little register and every little action. But then we were able to now just specify an instruction, and the compiler will take care of that low level. Do you like this now? So the assembly language, how we went from assembly language to now our programming languages we know now, is similar to now these threading strategies. Before you had to specify it yourself. Now we're kind of giving some of that job with the compilers and the runtime libraries only because we need it so often now. It seems like the more we need to do something, the more frequently we have to do something, then we always find another way to get it done automatically. And that's typically how things are done. If we have to do it so often, we want to make it automatically done so the programmer doesn't have to do it. And that's the stage you're at now. So there's 3 methods that are explored, and that's thread pools, OpenMP, Grand Central Dispatch. So do take a look at those different methods. And again, if you have any questions, bring them into the discussion forum. And other methods include Microsoft Threading Building Blocks. And this is the package for Java. So something for you to do. In the office hours slides, I gave you a link to the API reference library for Java. Here you go. You can look up the Java util concurrent package. Take a look at it. See what it is, what's there. And then I'll give you a clue and a glimpse how TBB works. What is the strategy? Again, everything is built by programmers. And in order to automate something, you have to then put it in a specific type of format. First, if you want the compiler to do it, or if it's going to be in a library. So class libraries are very in detailed, and they have a lot of material there for you or programmers to use. So typically, when you got to do some programming, look in the libraries first to see if it's already been done. So this way you don't have to write it from scratch. More than likely, it's already been done. And that's a way to then expedite any kind of programming or development that needs to be done. If it's there, use what's there. But make sure, in order for you to know what's there, you have to know the API reference library. That's the only way you're going to know what's there. So here's another chance for you to view the API reference library for Java. I did again include the link in the office hours slide. So take a look at that. And if you didn't attend the office hours, then view the recording. And again, or if you did, maybe you want to view it again. So thread libraries, typical to your libraries that you already know, or your packages that you already know with Java. And there is some lower level libraries for the kernel. I did mention there's kernel objects, as well as the API reference library has a bunch of objects, but there are special ones for the kernel. So again, review what a kernel is, look at what a microkernel is, and then see what kind of objects the kernel contains that can be used, that programmers can use. Things we will look about threads. Well, when you have a bunch of these mini little threads running, you have to manage them. And there's issues that come up where both are trying to be processed at the same time, and that can't be possible. And the kind of methods we have: fork, exec, which is execute, signal handling if it's synchronous or asynchronous, thread cancellation, thread storage, scheduler activation. Again, we have a process schedule, but if you have all these different now mini processes or sub-processes running, and they're trying to run at the same time, that's a lot of management that needs to be done carefully. So some of the topics, if you're looking, again, if you're taking the telecommunication and networking right now in that other course, you're going to look at some very similar situations. that things are going to happen, because it's all a matter of signals. Remember, the computer, we're just dealing with signals. So here in a network, you have signals going maybe from one computer to another. An operating system, you have signals going from maybe memory, from the disk to the memory to the CPU. So you can think of an operating system as a mini traffic enforcer within the travels within a computer system itself, across the motherboard and from RAM, as well as external storage or disks or your hard drive. It's very similar then to the other strategies used in networking, where you just have information going from device to device. But you will run into the same type of strategies. So do look for that relationship, and you will get a better and deeper understanding of the logic behind this management of all these signals. Windows threads, do take a look at that. Those are specific, obviously, for Windows. I did bring this up too. In office hours, we kind of looked at this. Again, you're going to have your parent thread and your children thread. So do understand how they are related. How is one called from another or called after another? Linux threads. One of your questions for this week is, what is the difference between how does Linux handle things as opposed to Windows? So here's the information right here. The way Windows handles it and the way Linux does. Linux uses clones, whereas Windows actually sets up a brand new process or a copy of a process in a new memory space. So those are your combinations, or comparison, I'm sorry. Okay, so these are data as the material for this week. You have, again, questions 3.2, 3.6, 4.11. For your exercises, there is a Dropbox. You will submit your answers. If you submit a file, then I could submit back to you comments in your answers. It would be an easier way to do it. So if you could, put it in a file and upload that file as your assignment. And also in the office hours, I did have additional questions that you can explore. Again, just for you, it depends how much you want to know this. The more you want to know it, then the more you got to explore the topics. This is a discussion question. Bring in this information. There were a couple already answers to this, and I offer new threads. And again, here's these questions. So if you, we did look at this. So I'm not going to go through it again right now because we already went into office hours. Review the office hours and bring in any questions you have then into the discussion forum. Okay, any questions? I know we're going a little bit over, but I hope this helped you in understanding what we are going to be doing next. Give you some direction on what you should concentrate on, and a strategy such as you have the topics, make up that, write out the definitions. You can put them in the discussion forum. You have some practice questions that you could look at, and then go from there. Do all the exercises if you can in every chapter. I don't know how much time you have, but if you could do all those exercises at the end of each chapter, then we are going to say you are a master operating system, or a master at operating systems. Okay, thank you and have a good day. This is recorded so you can review it again. And again, any questions, bring it into discussion forum. That's where we are going to sit around and talk to each other. Thank you. Have a good day.